and you will get a copy of this recording. I'll start recording right now. And let me get that picture back up here. Let me expand that whole page and let's have a look at these. Let me blow it up just a little bit. Is this correct that it start right there with 5D?
Yeah, so if you could maybe show me how to do one of each of them, and then I can probably figure out from there how to do the rest.
Okay, not as easy as that sounds.
Okay.
First of all, let's distinguish between quadratics that are first level and quadratics that are second level. Okay? This is first level because the coefficient of the x squared is 1. All of these quadratics are going to be extremely easy to factor. And there is a method that I teach that may not be the same as what you have learned, but my method's easy. And what they teach in high school is either the California method or the diamond method or whatever. But let me show you my method. You'll see how easy it is, at least on these first degree quadratics. Very first step is to split up the x's. You always split them up like that. You never split them up as x squared and 1.
Okay.
Okay? That's first step. Let's just list them. Split up x's. Second step, determine both signs. Not just one sign. Don't determine the numbers yet. Just figure out what both signs are. Well, notice what factoring is. It's the reverse of foiling. You were taught FOIL, right?
Yeah.
Okay. When you FOIL two linear terms together, you get a quadratic. Well, here we have a quadratic and we're going backwards. So when we FOILed it, the only way you can produce a negative number there is if your signs are opposite.
Okay.
They have to be opposite. Now, in this particular case, with a first degree quadratic, plus minus is the same as minus plus. There's no difference. So that's what I want. Now, the third step. Follow these 3 steps, you'll never go wrong. Factors of the constant that in this case, because of the negative sign in front of the constant, they need to subtract to the coefficient of the x term, which in this case is 10. So let's talk about factoring numbers. Over here on the left, if I want to find factors of 24, I always start with 24 and 1. Then if I can cut that in half, I do. Because I cut that in half, I have to multiply by 2. Again, I cut it in half, multiply by 2. Again, I cut it in half, multiply by 2. That's as far as I can go.
Okay.
Okay. So, what factors of 24 subtract, because of that negative sign, to the number 10? Not the positive 10 or negative 10, but just to the number 10.
12 and 2.
Okay. Put bigger factor with the sign of middle term. Okay, there it is. There's your 4 steps. Sometimes you don't even have a 4th step. Sometimes you just have the 3 steps. So, what's my answer?
X plus 12 and then x minus 2 equals 0.
Yeah. Now, when you've factored something and you want to check it, you don't necessarily have to FOIL it entirely back together again. And the reason is that you never get the first and the last term wrong. What is sometimes wrong is the middle term. So
Okay.
to get the middle term, that's the O and the I of FOIL, right? There's the O of the FOIL and there's the I of the FOIL. Well, multiply those two together, add them together, which is what you do when you FOIL it, and that produces the middle term, always. In this case, the middle term better be 10x. It is. You've done it correctly.
Okay.
Now I'm going to give you another simple one, and I want you to use these rules on it. This one I'm going to give you is real simple. First step.
Well, it's going to be x plus 2 and then x plus 5.
Okay. Believe it or not, I'd rather see you go through each of these steps, because
Okay.
I want to see you memorize these steps. You just did what most students try to do, which is come up with the answer in one step. And that's fine for these first level ones. I know you can do it, but let's just go through these steps, and then I'll give you a little harder one where you won't be able to necessarily do it like that in your head. So split up the
Okay.
x's. Both signs have to be positive.
Right.
Factors of 10 that now have to add because of that. Not subtract, but add to the number 7. And here I don't even have a fourth step because putting the 5, 2, and the 2 there is the same as the reverse. So this particular one only had 3 steps to it. I'll give you one more. First step.
Separate the x's.
Second step.
They're both going to be negative, right?
Oh, that would not produce a negative 20. In other words, if I did what you said,
Oh.
notice that whatever number I follow with, when I FOIL it, the last term of FOIL is that negative number times that negative number, which would produce a positive number. So
Right.
when you see a negative number in front of the constant, you know the signs have to be opposite. They could either be plus minus or minus plus, but again, it doesn't matter in this case. In other words, as long as the coefficient of each x is the same, then plus minus is the same as minus plus.
Okay.
Third step.
Find the factors of 20.
That do what?
That subtract to equal the x.
Not the x, the coefficient of the x. What's the coefficient of the x, the absolute value of it?
1.
Okay, what factors of 20 subtract to the number 1?
It would be 5 and 4.
Okay, now step 4. In other words, whenever this is a negative constant, you're always going to have this step 4, because you do have to decide which factor to put with which sign.
Okay.
So where's the 5 go? Where's the 4 go?
So the 5 is with the negative, the minus, and then the 4 is with the positive.
Perfect. I think you got elementary first degree ones down. And that's huge. because those are the majority of what you're going to get on tests. I mean, even when you go to take your SAT test, you'll have some factoring problems on there, but they'll be this type. They won't be number 6 type. Okay?
Okay.
So, if I'm looking at number 6, that's no longer an elementary quadratic. That's a harder quadratic. And it takes away these last 2 steps. You can't say anything of the 3rd step anymore. And I'll go through this with you. First 2 steps are still the same. Okay? So let's factor it down here. And I want to give myself a little more room to write. Let me factor it up here. Here. 3x squared plus 17x plus 10 equals 0. Step 1 still the same. What is it?
Oh, split up the x's.
So what's the answer?
So it would be, wouldn't it just be like x and then plus, and then x plus on the other one?
They have to multiply to give you that. When I say split up the x's, that's what I mean. In other words,
Okay.
come up with 2 factors that multiply together to give you 3x squared.
3 and 1.
Well, 3x and x.
3 and 1. Yeah.
You need the x. You don't need, just the coefficient. Determine both signs.
They're both going to be positive.
Okay. Now, we don't have any rules saying things like factors of 10 that add to 17. You can throw those out the window when you get to these 2nd level quadratics. And
Okay.
anything that has a coefficient other than a 1, I call a 2nd level quadratic. Okay? So now we just have to kind of look at factors of 10. And now it becomes a bit of a trial and error process. More than a bit. Okay? Now, you have to choose 10 and 1 or 5 and 2. Okay? Now, I would say 95% of the problems you're going to run into, at least in Colorado, are going to be the factors that are closest together. Just
Okay.
like the last problem was 5 and 4 that I made up, try 5 and 2 first.
Okay.
Okay? Arbitrarily, let's try 5 there and 2 there. Now, when you're dealing with 2nd level quadratics, you always have to check the middle term even to solve it. There's no way to really do it other than by constantly checking that middle term.
Okay.
Is that the correct middle term?
No.
Okay, that ain't the correct factor then. Well, there's only a couple other choices, but the first one I want to try is 2 there and 5 there, the reverse.
Okay.
And again, this is a trial and error process. You're looking at factors and you're randomly just trying them until you find one that produces the middle term. Well, what's the insides equal to when you multiply the inside of FOIL?
2x.
Plus 2x. I would use the plus sign here just because you're going to be adding it to something else that could be plus or minus. What's the outside?
15x.
Plus 15x. That adds to 17x, which is the correct middle term, which means we did it right. Now,
Okay.
had neither of those worked, in other words, if 5-2 didn't work and 2-5 didn't work, well, then I'd go try 10-1. That's the only other set of factors. And if those don't work, then you have to go to the quadratic formula. In other words, if you're factoring what I call standard quadratic factoring, if that does not work, then you have to solve it by using the quadratic. Okay? Okay, I'm going to erase that. Hope you got that memorized, those first couple steps. Let's go down and do a harder one. Now, before you factor it, what's the first step in factoring? You don't always go to the quadratic. First step in factoring is greatest common factor. And the reason is that sometimes you can take a really complicated quadratic like this and reduce it to where inside the parentheses it's a first level quadratic. Is there any number that I can take out as a greatest common factor?
Is it?
It's either 3 or nothing, right?
Yeah, it's all divisible by 3.
It's gotta divide evenly into each of those numbers. And 3 is the only thing that could do it. 4 isn't obviously going to do it. 2 isn't going to do it. So let's look about number theory for a second. Is that number divisible by 9 without, or by 3 without a calculator?
Like, can I do it in my head?
No. Here's a little trick. Add up the digits. What do they come to?
9.
If that number is divisible by 3, then the entire thing is divisible by 3. In other words, if the digits add up to 12, it's divisible by 3. The digits add up to 6, it's divisible by 3. Okay? So that's a neat little trick to use when you're looking at a problem like this, because I know you got a calculator. So, okay, so I'm going to take a 3 out. And what quadratic is left behind? If you don't have a calculator, you should always have one when we're doing a session.
Okay, yeah, I have a calculator.
Okay, so what's left after you factor out the 3?
It would be x.
Hold on. Every time you do a factoring like this, as you go along, check to make sure you got this term. Is 3 times x 3x squared?
No.
Okay, we need a squared there. Now it is. Okay, what's the next term?
18x.
Plus, I do need the plus sign there because it's part of a polynomial. And finally, what's that? 81.
Yeah, 81.
Okay, so now if that all is equal to 0, notice that I can divide both sides by 3. So now I have just x squared plus 18x plus 81 equals 0. Now I can factor it as a first level quadratic. Do it step by step.
Okay, separate the x's, and then both the signs are going to be positive.
Okay, yeah, when I say step by step, what I'd like you to say is x and x.
Okay.
Because sometimes there's multiple ways to separate the x's. In other words, when you get a harder one that's got like a 4x squared, well, now you can separate the x's by 2x and 2x, or you could do 4x and x. So there's sometimes more ways than is obvious to separate the x's. Okay, both signs are what again?
Positive.
And finally, this is a first level one, so you can use the rule. What's the rule? Factors of
81.
that do what?
Add to 18x.
Add to 18. Not add to 18x. Add to 18. And I don't mean plus 18. I mean they add to the absolute value of that coefficient. So what factors would do that?
9 and 9.
Okay. Now, we still haven't solved it. We didn't solve the previous one. I forgot to do that. How do I solve this for x?
Do you set each of them equal to 0?
Okay. So x plus 9 equals 0. So x equals minus 9. And then x plus 9 equals 0. So that solution must be the same. Now, typically when you solve a quadratic, you get two different solutions. Every now and then, with special quadratics, you get the same solution twice. That you'll learn later in your math career that is multiplicity of 2, as opposed to a normal solution where you each have solutions that are multiplicity of 1. All right, let's see. We got 5 minutes. Let's see if we can do one more of these really quick. At least one more. That one. Okay. Let's try this. Okay. Obviously, it's not first level.
Right.
And I can't do a greatest common factor to turn it into first level because I can't factor out of 3. 3 doesn't go into 8. 3 doesn't go into 4. So let's try the second level technique. Split the x's up.
So it would be 3x and then x.
What are the signs?
It's going to be both negative.
Good. They're both the same because that is what that means. They both have to be either both negative or both positive, and you look to the middle term to determine which. Since it's negative, they both have to be negative. Now, factors of 4. Here's our factors of 4. That's it. I can see 2 and 2 doesn't work, right? In other words, that's where I would normally start, because those are the two closest factors.
Right.
But if I put 2 and 2, that gives me a middle term of minus 2x plus minus 4x. That's minus 6x. That's not our middle term. Well, 2 and 2 aren't going to do it. So I'm going to try 4 and 1. And I'm just going to, I know, I can tell by looking at the middle number 8 that I got to somehow get up to 8. I'm not going to do it if I put the 4 here and the 1 there. So let's try the 1 there and the 4 there. Darn, that produces minus 1x minus 8x. That gives me a middle term of minus 9x. There is no other way to do this factoring. In other words, I can't split up the 3x in any other way, and I can't split up the 4 in any other way. Therefore, I can't factor it using normal quadratic factoring. And I have to turn to the quadratic formula. Do you have the quadratic formula memorized?
Yes.
Beautiful. What is it?
X equals plus or negative b plus or minus b squared minus 4ac over 2a.
Great. And you weren't reading that off of a piece of paper, you were pulling that from your memory?
Yeah, I know what the quadratic formula is.
Did they teach you a song to teach you that? No? Okay. Tell me what A, B, and C are for this problem.
So b is going to be negative, or it's going to be the negative 8, and then a is the 3x squared, and
Just
then
3.
c is
Just 3. These letters are just the coefficients. They're not including the x. Okay? Now go ahead and substitute. Let's come up with an answer.
X equals 8 plus or minus negative 8 squared.
That's
minus
always a
4.
positive. B squared is always going to be positive regardless of whether it's a negative or, because negative numbers square to be positive, okay?
Right. Minus 4 times 3 plus, or times 4.
I would always do that step. Never do that math in your head. It's too easy to make a mistake. Plus, frequently, you're dealing with a lot of negative signs. In this case, they're all positive, but nonetheless, do these, the secret of math and not making mistakes is trying not to do too many steps in your head at once. And that's not for you, that's for everybody, okay? That has nothing to do with your math abilities even. It's just that when one starts doing multiple steps, now here, the next step I do is always that, without the negative sign. Negative sign is still there, but that means subtraction. So I'm subtracting 48. Those three numbers multiplied together are 48. Still dividing by 6. Over here on the left, let's simplify this. 8 plus or minus the square root of 16 all over 6. You finish it.
It would be x equals 8 plus or minus 4 over 6.
What numbers does that give you for x?
2.
And
4 over 6.
2 and
which would be 2
thirds. Those are your two answers. And that is why I couldn't produce it when I tried to factor it, because when you factor, what the heck? I should have been able to factor it. What did I do wrong? I had 3x.
I think you put a 2x there.
Oh, it was factorable. Yeah, that made it minus 2x minus 6x gave us 8x. Okay. Had we factored, that's okay. I'm glad this happened, because this shows you that when you use the quadratic formula and you get rational answers, those are not irrational numbers. It's not like square root of 7. It's rational numbers. It means it should have been factorable. The moment I saw this, I said, well, that had to be factorable. I must have made a mistake. And I did. You're right. I split up the 3x squared wrong. I wrote 2x instead of 3x, and that caused me to make a mistake on the whole problem. And then if you solve this, you'll get x equals 2 or x equals 2/3. And that shows you how much quicker it is to do it by factoring.
Right.
In other words, you don't want to have to use the quadratic formula unless you have to. And there's always, I'll let you go here in a second. I've run over a little bit, but wanted to make sure I finished this particular problem. Okay?
Okay.
All right. Jess, I will let you go, and you guys have figured out how to schedule online, so I'll just let you keep doing that. If you do find a certain time of day, same day of the week, that you'd like to schedule something regularly, you can lock it in. It's not a bad idea to do, because I will tell you right now that for the next 2 months, I am going to be booked solid Mondays through Thursdays, 3 o'clock to 9 o'clock. It's going to be hard to find. If you're only looking for half-hour windows, you can probably find some. But if you want to lock it in and it's open right now, I can do that on my end if you decide you want to. Okay?
Okay.
Otherwise, I'll let you just keep making your appointments online. Sunday, there's always going to be availability. In fact, on Friday, Saturday, Sunday, there's always availability, or in the mornings. The only time I'm book really is really between 3 o'clock and 9 o'clock Monday through Thursday. And I have some spots open. It's just that they're going to disappear quickly.
Okay.
As we go into finals prep. I know it's still a ways away, but that's when I get really, really busy. Okay?
Yeah.
And I will send you a link. When you signed in, did you put your, jesselauk@gmail.com? Is that you?
Yeah.
Okay. That's where I will send the link so that you can see a recording of this.
Okay.
Okay? Jesse, have a nice rest of your day, and I'll talk to you next time.
Okay. Yeah, you too.